welcome or good afternoon to everyone. You've already been here for quite a bit today, but just want to thank you for joining me today, taking a big chunk of your afternoon to spend it with me, learning a little bit about data engineering. My name is Ramon, and I've been working in data for the past 6-7 years. I got my hands dirty about 6 years ago with a company, dirty with data, about 6 years ago with a company called Service Management Group. If you've ever gone to McDonald's, Hard Rock Cafe, Pandora, Starbucks, or any kind of fast food, from fast food to retail, and you've purchased something, and then at the end of your receipt, you see that it says, tell us about your experience. I work for that annoying company that makes you fill out those surveys for a coupon. So that's one point. Then my very first foray into any kind of data analysis was with a little project about sentiment analysis, with open-ended questions in Spanish for Walgreens and CVS in Puerto Rico, Florida, and places in the US where they speak Spanish. So it was really cool. I spent a lot of time there dealing with data, and then after that, while I was doing that, I was doing a master's in economics, so that's part of my background. Then from there, I became a researcher in Washington, D.C., and I was studying financial literacy. While I was doing that, I was also learning machine learning, teaching it on the side at a university, and then from there, I ended up in Australia, trying to build, or working towards building, a data science bootcamp. 2 years from that, I became a senior product developer at a company called Decoded, started creating workshops for some of the largest financial corporations in the world. And then in between those years, I was a researcher at NCR, a business school with a campus in Singapore, another one in France. And then I also got to teach a course at London Business School. So that's a bit of my background, intersection of education, technology, and machine learning. So really excited to bring you this workshop today. The motivation as to how it came about is that, well, there's a lot of tutorials out there on how to get started with data engineering. There's a lot of places that tell you you should do it this way, you should use this tool, you should be able to get started using XYZ approach. And the reality is that if you have never set up a server, if you have never deployed a container into an instance in the cloud, it's going to be quite difficult, or it's going to be a little bit challenging to be able to do that for the first time yourself. And if you do it, which I'm sure everybody here can, then the next thing is to service it and to make it work all the time, and then to keep track of what you're doing, when you're doing it, and why you're doing it. So I figure, well, how about creating a talk that will teach you just that. Create a roadmap where you can create a framework for yourself. Then if you don't want to create a framework for yourself, then can you actually adopt one without having to set up infrastructure on your own? And then lastly, can you actually see what a data platform will look like if you were to go that route and convince your team to adopt one, whichever flavor of data engineering or data platform you want to adopt. There's plenty of those out there. So the motivation of this, for this talk is to enable you to do things in data engineering, whether you want to do them locally at your own pace and create yourself your own tools, or whether you want to adopt a framework, or whether you want to adopt a data platform. So along the way, we're going to walk through a couple of examples, and instead of just showing you, hey, here's a data set, it doesn't matter, let's just teach you the capabilities. Let's actually do it through a fun example, or through an example that is a real use case. And this is about bike sharing in 4 different places across the world. Porto in Portugal, London in the UK, Seoul in South Korea, and Washington, D.C. in the US. All right, so actually, let me get started with this. How many of you have ever done any kind of data engineering work? Or actually, let me backtrack. How many of you have done data analysis before? Data analysis with Python? What about Excel? Okay. How many of you have ever done any kind of data engineering work or built a pipeline for whatever reason? And let me rephrase this. A pipeline can be anything from taking some data in an Excel spreadsheet or in a Google Sheet and taking it from, I don't know, from Google Analytics and then doing something with it, getting the mean, getting the average of something, getting the minimum value. That's a pipeline already. You're taking some data, you're doing something to it, and then you're presenting it to somebody, or you're using it for some reason. Anybody? Okay, I see more hands. All right, we're on a good path here. All right, so let me ask before we get started. Has anyone had any issues setting up the environment? Do you need any help from me if you have not been able to set it up? I'm going to take that as we're good to go. All right, sorry. To the requirements.txt, you're going to see, and let me zoom in a little bit. You're going to see all these frameworks, right? So you're going to take AWS Local, AWS CLI, and you're going to take local stack out. And then you'll be able to install the remainder of the packages in there. So thank you for bringing that up. All right, so we will not get there for quite a while, so you should be fine. All right, everyone, so I would love for you to navigate. Remember, if you clone this repo before maybe 10 minutes ago, 15 minutes ago, make sure you do another Git pull, because there's a latest version of the notebooks. And then once you are ready to roll, make sure you navigate to notebooks and then go to 0.1 from scratch. All right, so I love to start my lessons. I've taught quite a lot. I've taught data engineering in PyCon Chile. I've taught a couple of lessons in data engineering, the previous places that I've worked at. And my very first taste of data engineering was actually when I was working at NCR. I was in a team of 5 researchers, and we had about 500 million job descriptions from Singapore, from Thailand, from the US, from anywhere from the Philippines, from anywhere in the world. And all of those files from 2008 to 2020 had a ridiculous amount of different settings, different formats, different ways in which the files were stored, different things that were tracked. Job descriptions have evolved. We used to see, believe it or not, but data scientist was still a thing before it became data science, and then it was called more, a business intelligence analyst would be somewhat a person that will be considered a data scientist before the term caught up. So we're just seeing an evolution of different kinds of roles. But anyways, long story short on that one, I started working with all these files. I had them in AWS. That was my first taste in dealing with the cloud. And then going from one side to another, I said to myself, okay, this variable here, this other variable there, they have about 60, 70%, 80% missing values. Why don't I just take it out? And then it just happens that 30% of 500 million job descriptions is still quite a substantial amount of information. So I took out a couple of things that I shouldn't have, and we had to rerun the work, the jobs, and then that was about $200, $500 to run that. And while that doesn't sound like a lot of money, with a team with a very small budget that comes from grants and donations, that is a lot of money. So that was the first instance in which I realized, okay, there has to be a better approach to this, and so why not let's try to find it. All right, so I love to start my lessons with a quote that I find interesting or that I find that adds something to the context that we're going to be talking through, and that is, without a systematic way of to start and keep data clean, bad data will happen. And that's some of the things that I hope you get to see today. So one last thing before we get started. Okay, let me know who's using VS Code. Okay, who is using Jupyter? Who is using PyCharm? Who is using Vim? There's a person by there. Who is using something that I did not mention? What are you using? Let me know. What are you using? All right. So I'm going to use VS Code. I'm using Jupyter Notebooks. If you have issues with that as well, also let me know. So a bit of an overview. At a bare minimum, when you want to create data pipelines, some of the things that you at least are going to need, you're going to need for sure a place to store your data. You're going to need some sort of computational power if you're going to run some aggregation, if you're going to run a particular kind of calculation, and you're going to be doing it on data over and over and over and over, you need compute power. And then lastly, you need versioning, at least for yourself, because you want to be able to go back to the things that you did, to the data that you use for a particular analysis, to the data that you filter through to get to a machine learning model, to the data that you get your metrics from to build a dashboard for your stakeholders. So you're definitely going to want to keep track of what you're doing, when you're doing it, and why. So those are, at the bare minimum, you need those three things. But those three things, they don't necessarily have to be outside of your computer. They can be in your local computer. You don't need to go too far beyond to be able to do those three things. And that's exactly the essence of this first session. How can I do data engineering inside my computer? And then how can I extrapolate that? And then how can I go even beyond that? All right, so since the files that we're going to interact will most likely live in a remote server, we're going to first extract a copy of the data that we use and save it into our local files. We're going to transform that data. We're going to load it into a local data warehouse. Have anybody here ever heard of DocDB? Have anyone here ever interacted with a database? Have you ever queried data from a database? Use one yourself? Okay, cool. We have a few people. So usually whenever you have a system that is taking data from one place, transforming it, and then putting it in another, if that other place where it's being loaded at is going to be a place where other people are going to access data from, it's most likely going to be a data warehouse. And if it's going to be a data warehouse, it's going to be optimized for something called columnar data-oriented format, which in these days is usually Parquet. One particular database that is optimized for dealing with Parquet files and columnar format of data, which we'll see an example here in a second, is DocDB. So we're going to build a local data warehouse with DocDB, and we're going to save our tables there in a little bit. All right. So then we're going to version control our code and data using DVC and Git. We're going to create a command line tool to run all of our jobs. And then we're going to create a reproducible pipeline that can capture different workflows. Have anybody here ever built a command line tool? I got 1, 2, 3. Okay, cool. All right. Well, all of you will build one by the end of today. All right. So some of the things that I hope you walk out of here with this session is I hope that you're able to discuss ETL and ELT pipelines, what they are. I hope that you understand how to read and combine data from different sources. And I hope you are able to create pipelines using open source tools and develop command line tools. All right, so the data that we're going to use, I mentioned that we're going to be using bike sharing systems. Have anyone here ever rented a bike, any kind of city? One of those that you see in the docking stations and you go and put some money in and then you just grab it, deposit it at another place, and off you go. Anyone? I got 1, I got 2, 3, I got 4. Okay. So these bike sharing systems, they're amazing tools, amazing things to keep a city moving, to keep it more green, to keep cars outside of the out of the roads. So one of the things that governments want to do, in particular the South Korean government, which they gave a task to a group of researchers to create the best forecasting model that they could. Why? Because they wanted to understand how many bikes do they need to have available on each day of the next 2 years and on each hour of the day. So we're talking about they want 24 predictions times 365. So do the math. They wanted a lot of predictions and they wanted to have it consistently. They gave them a bit of information and they said, off you go. Why do they want this? They want to understand whether they need to build more, whether the demand is high enough that they can build more docking stations of bikes that people can rent in the streets, and if they need to improve the connecting routes between the old ones and the new ones because there are not pedestrian paths for bikes, paths for bikes. So they wanted to understand this, and it's a real use case. And then the other ones, the other data sets that we're going to be using, the one from England, the one from Washington, D.C., and the one from Porto, they have similar use cases, but they just release the data so that people can do whatever they want. So a couple of common things that we have here. We have time. We have a variable that is going to tell us what time it is on each given day for a couple of years. We have the count of bikes that we need, that if we were doing a data science project, that is what we will be trying to predict. And then third, we're going to have some information about what's happening around them. Is it a functional day? Is it a holiday? Is it... what season is it? Is it winter? Is it summer? Is it spring? And so forth. What's the temperature like? Is it snowing? Is it a functional day? Are they being serviced today? So all of these things add up to what we're going to be doing with the data. And then here are some, as you can see, not all of them think of things in the same way. For example, London only has one variable called date that has the date and the time, which you could say like, oh, they're being quite reasonable. They're just letting us see everything in one place. But then all the other ones, they put the hours separated. So they have hour, year. So now if you start thinking about terms of pipelines, and I'm assuming everyone here has built a function in Python before, even if it's a hello world function or take my name and print it. If you're taking a function, now you can tell that I'm going to have to explicitly say what kind of variable is my hour variable, what kind of variable is my time variable, because these data sets are time series data sets. We depend on them. So those are treated a little bit different than other data sets. All right. So what are the tools that we're going to be using? So I mentioned we're going to be using pandas. We're going to be using quite a few tools, and we're going to build a command line too. So the tool that okay, let me ask. Who here has heard of pandas before? Okay, quite a lot of people. Who here has used pandas before? Quite a few people. All right, so I'll do a quick demo so that those of you who have never used it before can actually have a taste of it. Then DVC is, okay, have anyone here ever used Git? Let me know if you have used Git. Have you tracked your repositories, your code before? Okay, we got quite a few people. So imagine Git is the same, but for data. You get to track things, you get to see what happened from one version to another, and then you get to do it in a similar way as with Git. Then IBIS. IBIS is a tool for abstracting, talking to a database. So if you like Python, but you don't like writing SQL queries, I must confess I am the most horrible SQL query writer ever. I can do it, but with a lot of work. So I am very glad and very happy for the people that created this tool, IBIS. It's amazing, and it really does serve as a layer between those of us who don't want to write SQL queries and any database out there that we can connect to. Then Typer is the tool that we're going to be using for creating command line tools. And then pathlib is the Python package, part of the standard library that we're going to use to manipulate our paths. One thing that I haven't mentioned, after just about an hour from starting, we started about 15 minutes ago, 20 minutes ago. We're going to take a 10, 15-minute break. Then after another hour, we'll take another 10, 15-minute break. I want to break it down, and I want to give you some cognitive load. So we'll take a couple of breaks as well throughout the session. All right, so let's get started. So let me ask first here, who has ever heard about data pipelines before and knows a little bit of the context? Who can describe for me what a data pipeline is? Can anybody tell me? What do you think is a data pipeline? Or how would you define it? How would you tell it to a 5-year-old? Want to take a stab? Go for it.
I would explain data pipeline as a place where you modify or move data from one place to another.
Yeah, like a flow. That's perfect. Awesome. So, and that's excellent. That's exactly what you do. You take data, you move it somewhere, you do something with it. But nowadays, there's a couple of approaches to doing that. And why is that? Well, computation has become cheaper and cheaper, but data has become bigger and bigger. So one is running faster than the other, and the other one is trying to catch up. So companies definitely want to charge you more, but they know that they can lower the price, and because of the speed at which data is increasing every single day, then they know that the economies of scales are going to be in their favors. So one approach is the one that is most widely used, or used to be the most widely used, or maybe still is the predominant one, is called ETL, and that's extract, transform, and load. So the extract one, imagine well, I'll give you an example with my case. I worked at an educational company. We had different kinds of programs. One was a commercial academy, and the other one was a apprenticeship. Apprenticeship programs in the UK are programs where your company pays the government, is paid by the government in less taxes to put employees through a program that will upskill them. Those programs have a ton of requirements. It's absolutely ridiculous, the things that they ask you to track from students. So we have about 10 different databases, or 10 different tables inside one database that have different information about students, about their homework, about their assessments, about their group work, about their attendance, about a million things. And all of those might live in the same system or in different systems. one of the jobs that I had to do for my company was to gather, create connectors to each one of those sources, put them all together, and then try to create a way that was coherent so that people could have a schema that would connect one database sitting in XYZ place to another database sitting in London, to another one sitting in New York, and so forth. And that can take a lot of time, but because the end result are going to be clean tables that everybody wants to query, then we can do the transformation in route. What does that mean? In route means that I grabbed it, I transform it, before it touches my servers, I already have it clean and in the pristine way in which I want it to be, which it never is. But that's the approach that a lot of companies still take and will continue to take, and a lot of systems do take. The new one is this one called extract, load, and transform. Why load? The reason why, or one of the reasons why industry has moved to load is because there's so much data and you don't need to transform. Data continues to increase and increase and increase, and you don't need to transform all of it before you know what you're going to do with it. So if you start transforming it, that means that you are adding costs. For example, modern data warehouses like BigQuery, Redshift, and others, what they do is that they charge you per second or per minute. They have a different pricing system where you are charged by the compute power that you use. So if I am transforming all that data, if I am taking, for example, everybody here has taken a survey, and that survey asks you rank something from most loved or highly satisfied to highly dissatisfied. So even if I have to convert those from 5 highly satisfied or 2 highly satisfied, 1 satisfied, 0 neither, -1 dissatisfied, and -2 highly dissatisfied, I still have to compute that. And if I have 1 billion people answering my surveys, then I'm going to run some compute. But if I don't need that type of information, why should I move it? I'll do it whenever I need it. So the approach that companies are taking to save some money is they're taking all of the data from all of the sources that they're gathering, they're putting it in something called a data lake, which is usually what they call a blob storage. A blob storage is you can think about it as an infinite Dropbox or an infinite file drive where you can put all the data you want over there, and it has a couple of characteristics. It has a timestamp and it has a key. And then that key matches, you can access that file via that key if you don't ever remember the name. Of course, it's easier to remember the name than to remember the key, but sometimes there might be a reason on why you need to do that. But nonetheless, extract it from different sources, put it into this data lake, transform it later on. And nowadays, the leading tool for transforming data is dbt. And I wanted to do a little showcase of dbt, but I feel like dbt deserves a tutorial in and of itself. And then it jumps a lot in between Python and SQL, but it is an excellent tool that if you ever have the chance to learn and you want to go into data engineering, absolutely do it, because it's paying off right now. A lot of companies are hiring people with dbt skills. If you have any questions throughout the workshop, please, just raise your hand or just talk to me. All right. So we talked about ETL pipelines. Yeah, go for it.
Yeah, it's related to the ETL because I'm working in a small company, and one of the decision points that we have to make is whether to go like sign up. We're hosted in Azure.
Yeah.
To go sign up, so like put it in a like storage, and then just ingest the ones that you need, so that
Yeah.
the cost is going to be minimized or optimized. But the other choice is to just go to a single database, like Postgres or Azure SQL database,
Yeah.
and then use like dbt to do the transformation. So, like in your opinion, what would be the most optimal for like a company who's just starting or building the foundation when it comes to data?
It's a small company, right?
Yeah.
I would say, so the question is, for small companies, does it make sense to put the data in a data lake, or does it make sense to put it all immediately into a database and then do the transformations from the database? So I would say it depends. If you have small data and it doesn't cost a lot, then put it wherever it makes most sense to you. If it's all similar data, then keep it at a database because it's just going to be easier for you to query that data and do things with it. If it's data, like if you have images, videos, text, and then you also have a lot of tables from customers, reviews, and things like that, then definitely think about a data lake, because when you don't use information constantly, you might want to put it in different kinds of storage modes. So there's some storage modes where you pay less because you don't access that data constantly, and there's some storage modes where you're going to be accessing it constantly and then you pay more. But so if it's not a lot of data So my answer is, if it's not a lot of data and if it's very, very similar, then it doesn't matter. Like, you can put it in a database, and there's ways for optimizing databases. If the data is very, very different, you have unstructured and structured data, then put it in a data lake and then find a way to mix, to create a schema so that you know that if you're getting a table and you need images that this user posted or uploaded to this, I don't know, whatever platform you use, then you can query them or you can find them. So, yeah. Cool. No problem. All right. One last thing, one last kind of pipeline that I didn't mention and is very important nowadays. So, a lot of data comes in from interactions with the users, but that data goes immediately to a database. And then the data engineers that created a pipeline and moved that data from the sources to a new data warehouse, then, okay, so that just went to the warehouse. But what about the marketing people? What about the sales people that want to put a new user? They want to put it in Salesforce to see if they can talk to that user and upsell them some sort of service. So that's what is called nowadays reverse ETL. I don't think the name is very intuitive, and it took me a while to kind of get it, but it's essentially data that has been processed, putting it back to applications for the business to use it. Marketing is going to need the emails of new users to send them relevant stuff. Sales team is going to need information for to just talk to future clients or to see what they can follow up with clients, and then finance is going to need information about everything around the business to track metrics and see how budgets are going along. So with that said, there's a couple of points that I put here, but you need data pipelines when you have data coming in, and you're going to have to use it, and you're going to have to combine it with something else, or maybe you don't have to combine it with something else, but it just has information that needs to be transformed. To be able to do analysis, we cannot do it on word. We can do it on words, but we have to convert those words into numbers. So you're going to have to do some sort of transformation. Also, sometimes you're just not going to get the same data, even if it comes from the same place. For example, if we have data on bikes, but they're not coming from the same government. In the U.S., which I don't know why, they use Fahrenheit. And then everywhere else in the world, they use Celsius. So they just try to make it really complicated for everyone else. They use miles, but everyone else in the world uses kilometers. Why? I don't know. So if you're getting data from one place and you're getting another one from another, then you're going to have to normalize it and put everything either in kilometers or everything in miles. But then at the same time, sometimes that might not depend to you. If your audience is in the US, then why would you put it into kilometers? It's going to be a headache for them to understand it. Also, you have to take account of your uses. But then for files, lastly, we mentioned the data warehouse, but the most common way of saving data nowadays is in a Parquet format for analytical purposes. Why? Because data is stored in a column. And I have a picture around here that I was going to show in a second. So this is on one side, you have the row-oriented format, which is every transaction is one row, that is one data point, and every column is a characteristic of that row. And then in the other one, you have the columns. I might not need, if I want users that are above age 30 but below age 45, then I don't want to look at the entire database and then find the users that I want because I couldn't filter them faster. And also, if I only want their income, why should I look at every single column? I just want the age column, the user, and the income. So if I just want those three, I just capture those three, and then I just look over those three. So that's the beauty of columnar database. You have columns, the data is stored as columns, but instead of as rows. So the difference between querying one column of Parquet files versus the other one is astronomical. It can be ridiculous, especially with the more data that we have coming in. All right, so time to do some coding. So for the very first example, I thought we would do something, and let me see, I hope the example is there. If not, I'll put it up very quickly. No, it's not there. All right, so I forgot add fire. Tiny data set for the very first example. It's already there. So if you do git pull, then you should be able to grab it. It's a data set that has fires, in Australia they call them, by the way, I used to live in the US for about 10 years, so I got used to there, they call it wildfires, and then in Australia they call it bushfires. So I use either now, and I might refer to one and then refer to the other as bushfires and then as wildfires. So the dataset can be found in Kaggle, and it holds total wildfires and acres affected from 1983 to 2020. And if you have seen the news lately, or in the past year, you have seen that, in particular, California and places around the West in the US have suffered from very wild fires, very, very large-scale fires because of global warming and because of temperatures rising. So anyways, we're not going to do much with it. It's for the sake of an example, but it's important to explain that this data set can be extremely useful for different use cases, but it is not, as you can imagine, in the kind of format that we want it. If you have never used, let me ask, have anyone ever used Jupyter Notebooks before? Have anyone not used them before? I got one person. Okay, so the way in which you run them is, if you're using, what kind of editor are you using? Sorry? Vim? Okay, so you might not be able to run the the notebook in Vim, but you can do it. Do you have VS Code installed? Do you have? Okay, I'll help you. So in the break, I'll help you out to set it up so that you can run it. There is a binding for running Jupyter Notebooks in Vim that I've seen super hacky, very, very cool. I don't have the level of expertise to show you how to do it in Vim, but I can definitely help you set it up in a little bit so that you can do it with the notebooks. All right. So you can run the notebooks if you are using it like me. You can run it with Shift-Enter in VS Code, or you can click the Run button, Run by line here, or you can click the Play button on the left-hand side. If you're in Jupyter Lab or in Jupyter Notebook, you're going to have a little button at the top, a play button that is going to allow you to run the cells. If you have any issues running them, let me know, or if you have any errors. All right, so the first thing is that the notebook right now that we're in is not in the main data file. If you open up a new cell, you're going to see that the current working directory is going to be the notebooks. So in order to capture the data, you have to capture the current working directory. You can do it in many ways with the path library. Then you go into the parent directory, which is one above, which is the main one for the workshop. And then we're going to go into the data folder. In the data folder, so now that we have this element here that has our path, so it has the path that we need, then we can go into the examples folder. Also, if you have a Windows, it is possible that you're going to have to shift this one to this one if you have a Windows computer. So make sure you keep that in mind. I forgot to mention that. So we have our data file. We're going to get our example. We're going to go into our example folder, the one that I just pushed. If you don't have the example folder, remember to do a git pull on the repo, and then you will have it immediately. So then we're going to evaluate the federal firefighting costs. So we have acres of land affected by fires. We have the Forest Service charges, the DOIA agencies that were involved, their charges, so in helping but put out those fires. And then you have the total cost that this amount of fires, 82,591 in 1985, affected or cost for this amount of acres. So it's a lot. But now, what kind of problems can you see there? You can probably notice that we have the dollar signs and that we have the comma there. This is not Excel. This is raw code. So we cannot analyze data that has text because Python interprets it as an object, and an object is also similar to a string. So if you were to check the types of all of them, you're going to see that all of them are called objects, even though you see a numerical value here. So we need to get rid of the dollar sign, and we need to get rid of the comma. Remember, this is a toy example for the first part. And then the only one that is actually numerical is the year, because it doesn't have a comma, or it doesn't have anything else around it. And Pandas detects it with the appropriate data type. All right. So the first thing that we need whenever we're going to try to create pipelines is we need a function that is going to allow us, or at least give us some flexibility to extract data from different sources. The first one is not very flexible, as you can see, but it just serves our purposes to showcase one example. Then we're going to get more. We're going to add more and more. So in the first one, we have an extract function. And then in the second one, what we want to do is we want to take the columns from the data frame that we create, and we want to get all of them but the last one. And then we're going to replace everything that is not a number, and then we're going to change the type of that column into integers. So again, I'm replacing everything that is not between 0 and 9. I am replacing it with nothing, and then I'm changing the type to integer. Then I'm returning the data. Then, oops, I got to run this one. Then lastly, the last thing that we want to do, we want our last function to load. We want it to take the data. We want to give it a path. We want to tell it, hey, this is where I want this file to live. And then I want a little message that says, if I was logging, if I was doing something for for an application that is going to constantly be running, I will probably log information rather than just print it to my screen. But for the purposes of an example, we're going to say successfully loaded the modified data. So lastly, we're going to we have the data path that we created earlier. And then we want to add to that data at the back, we want to add the example, and then we want to add the new name of our new file. So we're going to call it mytest.park. And then the last function, so we have three functions, extract, transform, load. We have one last function where we create our workflow. And then in that workflow, so we take our data in, we clean it, and then we load it wherever we want to load it at. And then we also say, your pipeline ran successfully. All right, so here is our example. Example data out. I forgot to run this one. And there you have it. Now we have successfully loaded your modified data. Your pipeline ran successfully. So then if we want to make sure we actually did something with it, we're going to have to see, where's the data at? Did we actually do something with it? Okay, so here we are reading our data, remember the example data out, and then we're going to create a plot. If you've ever seen everybody here has seen a line plot, at some point, somewhere. And then, so in the x-axis, I'm going to have the years. In the y-axis, I'm going to have the Forest Service fee. Remember that was an object, but now it's meant to be an integer. So if that didn't work, then that's going to give us an error. The kind of plot that I'm going to do is a line chart. And then the title of that plot is going to be Forest Service cost by year. The reason why you see a little semicolon at the end is because matplotlib, the engine for plotting in Pandas, does not outputs a string of numbers for the ID of that plot. And then because we don't want to see it, you can get it out of the way with a semicolon at the end. So here we have a little plot, and it says the cost for fires have gone up over the years, although you can see that between 2000 and maybe 16, 17, the cost of wildfires went down very dramatically. So for those climate change deniers, this was probably a party for them. And anyways, but it continues to go up regardless. So our data pipeline worked. We built a little tool to showcase what we want to do later on. Now we want to make that more robust. And not only do we want to make it more robust, but we want to make it so that we can reuse it later on. And there's a few ways in which we can reuse a framework. We could keep it. We could keep the code in our computers and copy it to a new project whenever we need to create new pipelines. We could create a package and either upload it to PyPI or put it on GemFury. So GemFury is a really cool place where you can put private packages. And you might think, oh, why would I do this if I want my stuff to be open source? Well, private companies that have private data, or sensitive data that they cannot share with people, they are constantly building packages as well. But they cannot put it into PyPI, where everybody can download a package. So one of the tools that people use is GenFury. They will give you a little token, and then with that token, you will be able to download your files. So very cool. Check it out if you ever have the need for creating a private repository. Lastly, we could keep the data neatly organized in GitHub and clone the repository for every single time that we're going to do a project. If you've ever heard of something called dot files, then this is sort of the same approach. Dot files are files that you create so that whenever you restart your computer or whenever you open a new computer, you want to have the same setup that you had in your personal one. So I have done that with, I do it now. I have painfully realized the need for that, but it's extremely useful, especially if you start dabbling into the world of the cloud. You're going to be running instances in the cloud. You're going to be running a computer that might be somewhere around the world, and then you want your setup to be there ready to go. Not be there ready to go, but so that you can call it with one script and then put your computer the way you want it to be. So that's a very useful tool. All right, so those are some of the approaches that we can take. I'm sure there's got to be way more out there, but so the next thing that you might want to do is you might want to set up a development environment. Or not might, you probably do. If you want to take that approach where you want to create your own package and then manage it as such, whenever you're going to add new functions, you add new functions, you test it, you push it to GenFury or you push it to PyPI, and then you bring it back down. So you might want to start with setting up your development environment. And one of the things that you want to do, you want to take different approaches. You want to either use setup tools or you want to use, I think it's Poetry that allows you to build packages nowadays. But the one I like is MVDev, and that is by the people at FastAI. It's a really, really cool package, and it allows you to create your Python packages inside Jupyter Notebooks. So it builds almost everything you need, and all you need to do, or all you need to focus on, is in writing your code. Then with a few commands, you have a package published to PyPI. So very worth it, 90 minutes, that will make you really, really get going with creating new packages. All right, so the first thing, by the way, again, interrupt me if any questions come up. Just raise your hand, just start speaking at me. All right, so for the first part of what we intend to do, we want to create a few functions. We mentioned that we have a couple of files from different countries. We have bikes data from London, from Seoul, South Korea, from Washington, D.C., and from Porto in Portugal. So if you can see, yeah, you can kind of see it. Yeah, you can see it. Okay, so the London one is a database, London Bikes DB, and it's a SQLite database. The Porto one is a Parquet file. The Seoul one is, let's see, is a CSV file. And then the Washington, D.C. one is a JSON file. So now we're kind of like seeing what data might come in. So, by the way, even though you have the links to the websites where you can find the data sets for those, the one for London doesn't come in a database. I put it as such just to illustrate this example. The one for Washington, D.C. comes as a CSV, and the one from Porto as well. But I put them as such so that we can see different cases, different use cases. All right. For the extracting, there's a couple of things. So if you think about why, if you think about extracting data, you might think, okay, this is very straightforward. But sometimes you actually have many barriers to, or many things that you need to like jump over to be able to access data. If you think about healthcare and finance, and maybe I'm missing one more, but healthcare and finance in particular, you have a lot of sensitive data. And in that sensitive data, you're going to need permissions from people to be able to see it. For example, imagine the health of a person, or the background, the medical background of a person. You might never be able to access that without asking 10 people at a hospital or a different place about, hey, how can I access this? How many layers do I have to go through this? So that's one case. On another case, in the finance world, you might want to use information, banking information about the transactions that I do in a month. Nowadays, there is a way of accessing transactional data without that you can bypass banks. It's called open banking. Have anyone here ever heard of open banking? No one? Okay. Imagine there's a new banking app in the Philippines, and they can give you the best looking budget that you've ever seen. They learn from your purchasing behaviors and try to give you ideas as to how to save more, how to have more, keep more money in your account, how to invest it. They tailor a path for you to become more wealthy. Imagine like there was this app, but all they need is access to your data, and they cannot do it because they're not a bank. So your bank cannot create such a tool because they are heavily regulated, and they have to tell the government exactly what they're going to do with your data. So they might not be able to do it, but a startup might be able to do it. But the startup is not going to become a bank. So we got a chicken and egg problem. So what's the compromise that both sides did? They created an open set of standards called open banking. And what they do is that if you say right now you want to give access to someone, you want to give access to your data to someone that is going to give you something beneficial for you, and you're going to pay them. You're going to pay them $10 a month for that budgeting app or for that cool feature with your money that you want to do. So that can be done nowadays. But there were hoops that you needed to cross. And then there's two companies that in this space that got created exactly for that. There's so many barriers to, or there can be so many barriers to accessing data, that there's two in particular. One is called Airbyte, and the other one is called Fivetran. And both of these companies have, or one of the, Airbyte has an open source version of a tool that allows you to take, as you can see in this little image that they have here, they allow you to, they are the extract piece of your data pipelines. And they allow you to make, they have connectors to different databases, different data lakes, different types of storage, and they give you a component that allows you to create your own custom component. If you have a particular set of tools that the data is coming there and you don't want to touch it. Why extracting can become a problem too. Imagine companies that still have legacy systems running behind the scenes. They're probably going to have one that they just cannot touch, and it's what they call a house of cards. If you touch it, it's going to fall. So they might have one that nobody wants to see break, so nobody changes it. And then they have another that is completely new. So you're having the same data coming from two different sources, and now you have to build a custom one for that old one, and the new one might just be available. So those are the problems that these companies are solving. So without chatting too much about that, the first thing that we're going to use, if you have never used URL lib, is in the standard library of Python, so you don't have to install it. It's pretty cool. It allows you to do a lot of cool stuff with accessing data from the web. It's similar to request, but it serves different purposes. So the first one that we're going to do is, imagine that the data lives in a place that we just cannot read the data from there. So we're going to have to download it, and we're going to have to put it somewhere. So what we're doing here is, we're taking the URL of wherever that data lives at. We're taking the path that we're going to put it at. I'm going to put it in this folder in my computer, in the documents folder, or whatever. And then I got to give it a name. So I take the path out. I check whether that path exists. This is a really cool, if you have never done that, if you have written code over and over and over, and you have never checked whether a path exists, and it breaks your head because you have to go and create it every time before you can actually run your functions, then check that one out, because you're gonna find it useful. Usually, people will see the if-else statements like this. I just didn't see a need to have it in 2 lines. So we take the URL with the data that we're going to download, and then we put it into a place that we're gonna access it from. So what does get and load file do? Or sorry, URL lib does if you don't specify a path? It puts it into a temporary folder, and then it just lives there until you do something with it, or until you reset your computer, and then it's gone. Okay, so we check that our function works. And let me actually close this down over here. This is the URL where this data set exists. If you ever want to check it out, it's in the UCI, or University of California, Irvine, machine learning repository. So this is the one for SO, and you can read here that they, parent directory. View all datasets. And here it is, bike sharing demand. So you will be able to see here like articles or links to, or references to the to the 2 academic papers that were published with this data set. So this is an actual use case from the government of South Korea. They gave it to these people. They say, we need the best forecasting model you can ever build for us. All right, so without getting derailed, let's check that that worked. Let's download our file. Make sure that that works. It might take you a few seconds. The data set is not big, but we all know that the network is a little bit flaky today, so that's okay if it runs for a little bit. We still have it with us because we downloaded it from GitHub. All right, so if you want different tools to do the same job, there's another really cool tool called wget that you can pip install and then swap the URL lib request. So then the next one that we're going to do, remember that this was the file from Seoul, right? And then this is our file from Seoul. It's actually not in the best of encoded. It's not encoded in the most friendly. It's not encoded in UTF-8, which is the normal type of encoding that you will find text files in. What it is in something called ISO something. So we want to make sure that our next function actually takes that parameter there and allows us to say, hey, it has this type of encoding. So that's what we're going to do. So in the extract from a CSV file, we have the extract from a CSV file. We are going into the Seoul folder that everybody has, the raw file, and then getting our bikes data. And then we can see that this works. We haven't put an encoding yet, but this just works for us. But if it were to happen, then we will have to add it. All right, so this is what we have. As you can see immediately, we have a lot of things in the variable columns that we're definitely not going to need or we're not going to use. So we're going to have to do something with that in a little bit, but we're still in the extract stage. All right, the next one is we're going to read the Parquet file. The Porto dataset is stored as a Parquet file, so you remember the columns rather than the rows. Does anyone know what this is? Have anyone seen this before? Can anyone tell me? Keyword arguments, yes. And then what does those two stars do? The what, sorry? Right. So this is a particular Python hack. If you put 2 stars in a keyword argument or in a dictionary, it's going to separate them all and it's going to allow you to put them as options. So it's the same as adding. So it's the same as if you add 1 key here and then value, and then you add many more and many more and many more. And you have many things there, and then it unpacks it. So it puts it as different arguments to your functions, because we are using here a pandas function. Okay, so now we test that it works and that it reads our Porto bike sharing hourly Parquet properly, and it does. And as you can see, we still have a lot of information that it just doesn't match any of the other ones. So if we're going to put this in similar tables, but it's going to be the same information with different variable names, then that's not going to be very useful for us. We definitely have to normalize it at some point. All right. One of our files is stored as a SQLite database, so we will use the SQL 3 module, which is part of the Python standard library. It's a very lightweight database and very useful for testing applications, for debugging, for doing things that you don't necessarily need them to scale, but it could, and you just need something easy and fast. So with SQL, we need a connection to a database. So we need to give it a path where we know our data is in or our database is at. And then the next thing that we need a query. So we're going to pass in the query, and then the next value is going to be the connection. And then that connection is going to say, yep, this query is going to be transferred to this database that I am connected to. Voila. And then the PD is going to give us a data frame. Again, similar to the one that we have here. And then lastly, is a JSON file. So JSON files, if anyone here has dealt with JSON files, then you know that it can be quite tricky, quite messy. They can be awful to work with. They can have different encodings. They can have an extra quotation at the end, so you have to read line by line. So I am not pretending that I am covering every single use case for reading JSON files, I am just assuming this one's going to be nicely behaved. And if I need to change it, I change it later. So we have a try and accept. We first try with pandas, and then we try with plain Python, and then we put it into a pandas data frame, if that ends up working. All right, so lastly, we test that that works. Check that that works, and then we have Washington, D.C., and notice that the temperature is quite weird here. It's kind of like a decimal. I don't know if that's 24 degrees, but somebody decided that it would be funny to mess with someone and put it as 0.24, but I don't know. All right, so now we have all of our extract and transform, all of our extract functions. How do we create a command line tool from that? So what we're going to do now is exactly an hour since we started. We're going to take a 10-minute break. We're going to come back at 2:50, and then we'll continue on what we left off, okay?